Let's go through now an example where we see the entire process, from analyzing what the roots look like all the way to estimating the irrational root. Now this problem tells us that the polynomial has no rational roots and exactly one irrational root. But our first step is to show that that's the case, which uses the same process that we would use to discover that that's the case if we didn't already know. So first we're going to use Descartes' rule of signs to analyze what real roots this polynomial actually has. Our original polynomial has one sign change, so we have one positive root. If we plug in negative x, that just changes the sign of that first term, because everything else has an even power of x. This has no sign changes, so we have no negative roots. So we know we have one real root, and it's positive. The possible rational roots, well, we've got our constant term is 7, and our leading coefficient is 1. So we have plus or minus 1, plus or minus 7. But we know our root is positive, so the only possible rational roots are 1 or 7. Since we know we have no negative roots, 0 acts as a lower bound. Okay, let's see if either of these possible rational roots work. The problem told us they wouldn't, but we need to confirm that. So we'll try 1 first. Our coefficients are, we have 1x to the 5th, minus 6x to the 4th, 0x to the 3rd, 0x squared, 0x, minus 7. If you find that you sometimes lose track if there's a bunch of zeros, you might find it helpful to write in the powers of x, just small, off to the side. So now we'll go ahead and do this synthetic division. We're going to start with 1, bring down the 1, times 1 is 1, minus 6 is negative 5. Times 1 is negative 5, plus 0 is negative 5. Times 1 is negative 5, plus 0 is negative 5. Times 1 is negative 5, plus 0 is negative 5. Times 1 is negative 5, and minus 7 is negative 12. So notice this is not an upper bound because I've got a positive number and a negative number here. Next, let's try 7. So bring down the 1, times 7 is 7. Plus negative 6 is 1. Times 7 is 7. Plus 0 is 7. Times 7 is 49. Plus 0 is 49. Times 7 is 343. Plus 0 is 343. Times 7 is 2,401. Minus 7 is 2394. Okay, that's definitely not a root, right? It is an upper bound, however. So we know that we have one real irrational root between 0 and 7. Okay, we'd like to narrow it down further than between 0 and 7, and we're going to get our calculator's help for that. Just to save a little space on my page, I'm going to put my XY table here in the upper right corner. I want to look at x values and y values. And my x values are just the numbers from 0 up to 7. And then to find my y values, I'm going to go to my calculator. I'm going to go to my table, enter my polynomial, x to the 5th minus 6x to the 4th minus 7. And I'm going to start at 0. So my y values are -7, -12, -71, -250, -519, -632, and then we've got a -7 and a positive 2394. So that's where my y value goes from negative to positive. Our real irrational root is going to end up being between 6 and 7. And now I can start narrowing that down. I'm going to set up a table to help me keep track. So A, that's my left end. That's going to start at 6, where my f of x is negative. B, that's my right end. That's going to start at 7, where f of x is positive. Then I'm going to have the distance between them. And remember, the problem told me I wanted to be within 0.1, so I want to get that distance down to be less than or equal to 0.2. And then my test value of c, that's going to be the midpoint, and I'm going to take f of c. And I'm not going to write down the entire value of f of c, just whether it's positive or negative. So starting out, my left end is 6 and my right is 7. Those are 1 apart, and the midpoint is 6.5. To find f of that, I'm going to take 6.5, store it to x, and enter my polynomial. X to the 5th minus 6x to the 4th minus 7. And that's positive. 6.5 is going to be my new right endpoint. Left endpoint stays at 6. Those are 0.5 apart. And the new midpoint is 6.25. Now I'm going to put that in my calculator. So I'll put 6.25 into x. Evaluate my polynomial again. And that's still positive. So that's going to become my new right endpoint again. 6.25. The distance between those is 0.25. We're getting close. And the new midpoint is going to be 6.125. So 6.125, store that in x, grab my polynomial again, and we still got something positive. 6.125 is going to be our new right endpoint. The distance between those is 0.125, which is less than our 0.2. So now we just need to find the midpoint there. That's another job for a calculator. We get 6.0625. And that's where we're going to stop, because that actually is our last midpoint. The one positive rational root is 6.0625 plus or minus 0.1. If we want to make this look rounded, well, looking at the endpoints that we actually have, we could also say 6.1 plus or minus 0.1, because the 0 is between 6 and 6.2. So once we get down to that final step, we have some wiggle room without even calculating anything more, as long as we can guarantee that the 0 is between our number minus 0.1 and our number plus 0.1. We're okay. Stopping here is fine, Adjusting to get something that looks nicer is also fine. Just make sure that you're sure that the 0 is really in the range that you're claiming.